Now, what do you do in telecommunication devices? Al-tata sutayad di mother to uwe, yo impermeability pakara, impermeability ch ubaji puri nose, impermeable. But clakwale pakare, hard, they should be hard enough. Our third, chemical resistance pakara. So dil tasta sa pakari. तेरे मोबाइल टेलीफोन जोड़ा है, सेल फोन जोड़ा है, आगे किस्ता हाई परमिटिविटी पका तेरे वे चाहिए तो पकाई कबले के चीनी जो लेगी ना के चीनी बड़े रखोगे कि न लग बलेगी का चीनी दे रखोगे नहीं ब्याह बड़े रहेगी ना चीज परमिटिविटी तो सेवा के न सर्किट साइज पर डिक्रीज इट इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर रूट ऑफ द सर्किट साइज दैट permeability dielectric constant when you increase it you decrease the circuit size. This is the TIF. It is the temperature coefficient of resonant frequency. You put the sample in a mana nungna mi ma sabak bas kere upati ni sta so masharano to masanga a okro agit so cavity. You put the sample in a cavity and put it over a hot plate. So you heat the sample and measure its response with the network analyzer. And if the resonant frequency changes too much with temperature, what does this mean? This means your cell phone will work in one way in Peshawar and in the other way in Murray. But if the resonant frequency is not changing too much, then it will work equally in snowy weather as well as in the hot weather. And thirdly, the property which is needed is the loss, QF, quality factor. It is the inverse of loss. If the signal is lost, the unit cell is like a room. If the cations and anions are at fixed position and there is enough room for their oscillation, no heat will be produced and the loss will be minimum. But if the room is a bit smaller and the cations and anions are closer, their movements will create heat and that will increase the loss. When the loss is increased, your signal will be lost in that material. Basically, you are preparing a resonator for your mobile phone. And if the signal is lost inside the device, then it is of no use. So you need three properties. Number one, you want to make a portable device which you can put in your pocket. Secondly, you need that the signal is not lost. And thirdly, it works equally at high or low temperatures. And for this, you design this product. That you have titanium oxide, you have strontium niobate, and you have strontium titanate. One has one set of properties, the other has other set of properties, and the third has other sets of properties. Yo ke pogwale ne, balki trikhwale ne, or balki poswale. To pogwale, trikhwale, poswale ra yo ze ke, our product ke jo rahe. This is engineering of material. Sta lig ER pakar de, nataba paki lig ER wache. आगे प्रोपोर्शन सर बे वाचे द दिस स्टैंडर्ड फार्मूली पर तवकल बाने जाने जोड़ेगी दरअसल स्टा द टाइप चीज़े न दाने कम पकार दे न तब कम वाला टाइप मटेरियल बोरे क्या पकेवा चाहे टाइप कर लका करावली no as a whole ba तिचे कम प्रोडक्ट जोड़ के न आगवा द ताला द microstructure property और द processing सेते पर कम टेम्परेचर बाय कूल के फास्ट कूल के नता तब आगा प्रोडक्ट दर की स्लो है फास्ट तो स्लो कूलिंग के से फर्क दे से दे याफ्तो न के तेज दे याफ्तो को रो दे याफ्तो आगे को फर्क न राजी पके because you give enough time to the ions to reorient themselves. When you are slow cooling a material, you give enough time for them to reorient themselves into a different structure during that cooling. So if you need crystallization, then you will have to engineer the cooling and the heating rate as well. Whether you want to avoid crystallization or you want to enhance crystallization, again you will have to engineer that